Hi friends, today I am giving a lecture on 8 queens problem in backtracking. So backtracking is one of the algorithm design technique. So 8 queens problem or n queens problem is one of the application of backtracking. So in backtracking, for a given problem, we have to find out all the solutions for a given problem. So all the solutions can be represented by using a state space tree. So in the state space tree, we have select only the solutions for the given problem from the root node to leaf node. So all the solutions are collectively called as state space tree. So now we are going to 8 queens problem. So in 8 queens problem, we have to place 8 queens on 8 by 8 chessboard. Okay, in 8 by 8 chessboard, the rows can be numbered from 1, 2, 3, 4, 5, 6, 7, 8. The columns can be numbered from 1, 2, 3, 4, 5, 6, 7, 8. The rows can be numbered from 1 to 8. The columns can be numbered from 1 to 8. The queens can be numbered from 1 to 8. 1, 2, 3, 4, 5, 6, 7, 8. The queens can be numbered from 1 through 8. So these 8 queens can be placed on 8 by 8 chessboard such that no two queens are on the same row no two queens are on the same column or on the same column. So no two queens are on the same diagonal. Okay, we have to place 8 queens on 8 by 8 chessboard such that no two queens are on the same row, no two queens are on the same column, no two queens are on the same diagonal. So these are the constraints we have to follow in 8 queens problem while you are placing 8 queens on 8 by 8 chessboard. So here we have to follow 2 types of constraint. One is we have to follow 2 types of constraints. Types of constraints. One is explicit constraints and second one is implicit constraints. So explicit constraints are the rules which restrict each xi to take on values from a given set. So here the solution vector is so x1, x2, x3, x4, x5, x6, x7, x8. Okay, so these solution vectors represents the column numbers. Okay, suppose we can take x1. So x1 is nothing but we have to place queen 1 in which column. x2 is nothing but we have to place queen 2 in which column. x3 is nothing but we have to place queen 3 on which column. x4 is nothing but we have to place queen 4 in which column in 8x8 chessboard. x5 is nothing but we have to place queen 5 in which column in 8x8 chessboard. x6 is nothing but queen 6 can be placed on which column in 8x8 chessboard. x7 is nothing but so 7th queen can be placed on 8x8 chessboard. In which place we are placing? x8 is nothing but 8th queen can be placed on which column in 8x8 chessboard. So here the set S suffix I contains only the set of 1, 2, 3, 4, 5, 6, 7, 8 is nothing but we have to place 8 queens on 8 columns in 8x8 chessboard. So S suffix I contains the column numbers, that is 1, 2, 3, 4, 5, 6, 7, 8. So X suffix I can take the values either 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8. So suppose X suffix I 1 less than or equal to I less than or equal to 8. X suffix I can take the values between 1 less than or equal to I less than or equal to 8. Suppose we can take x4, that is 4th queen can be placed on which column? Okay, x4 is nothing but 4th queen can be placed on which column among these 8 columns. Okay, so these constraints are called as explicit constraints. Explicit constraints. So explicit constraints are the rules that restrict each xi to take on values from a given set. So given set contains only 8 column numbers, that is 1, 2, 3, 4, 5, 6, 7, 8. Each xi to take on values from a given set from 1 to 8. So these constraints are called as explicit constraints. Next, what are the implicit constraints? So implicit constraints are no 2 queens are on the same column, no 2 queens are on the same diagonal. So no 2 queens are on the same column, no 2 queens are on the same diagonal. We are not mentioning the rules. According to the rule, so queen 1 can be placed on first row, queen 2 can be placed on second row, queen 3 can be placed on third row, queen 4 can be placed on fourth row, Queen 5 can be placed on 5th row. Queen 6 can be placed on 6th row. Queen 7 can be placed on 7th row. Queen 8 can be placed on 8th row. So 8th queen can be placed on 8th column. 8th column. So because of that one, we have not mentioned the no two queens on the same row. So these are the explicit constraints and the implicit constraints we have to follow in 8 queens problem, while we have to place 8 queens on 8 by 8 chessboard. Next, how many number of possible ways to place 8 queens on 64 cells, that is 8 by 8 chessboard? So suppose any queen can be placed on any cell in among 64 cells. Okay, any queen can be placed on any cell in 64 cells. So how many number of possibilities are there? So 64 possibilities are there for each and every queen. Okay, next, how many number of queens can be placed in 8 by 8 chessboard? That is 8 queens can be placed on 8 by 8 chessboard. So that is how many number of possibilities? How many number of possibilities to place any queen, to place any queen in 8 by 8 chessboard. 8 by 8 chessboard. So there are 64 possibilities are there. Okay. So 64 possibilities, we have to place 8 queens on 8 by 8 chessboard. That is total number of possibilities to place 8 queens on 8 by 8 chessboard is 64 C8. So here we have not applied any explicit constraint and any implicit constraint. Without any constraint, so any queen can be placed on 8 by 8 chessboard. How many number of possibilities are there? 64 possibilities are there. We have to place 8 queens on 8 by 8 chessboard. The total number of possibilities for 8 queens is equal to 64C8. Okay. After applying explicit constraints and implicit constraints, so the number of possibilities can be reduced. To 8 factorial possible ways. 8 factorial possible ways. The total number of possibilities for placing 8 pins in 8 by 8 chessboard is 64C8 before applying any these constraints. So after imposing the explicit constraints and implicit constraints, the total number of possibilities can be reduced from 64C8 to 8 factorial ways. 8 factorial ways. Okay. The total number of possibilities after applying explicit constraints and implicit constraints is equal to 8 factorial. Next, one solution is 4, 6, 8, 2, 7, 1, 3, 5. So, first queen can be placed on 4th column. Second queen can be placed on 6th column. Third queen can be placed on 8th column. Fourth queen can be placed on 2nd column. Fifth queen can be placed on 7th column. Sixth queen can be placed on 1st column. Seventh queen can be placed on 3rd column. Eighth queen can be placed on 5th column. So after placing 8 queens, we have to check no two queens are on the same row. So each and every row contains only a single queen. First row contains only this queen. Second row contains only this queen. Third row contains only this queen. Fourth row contains only this queen. Fifth row contains only this queen. Sixth row contains only one queen. Seventh row contains only one queen. Eighth row contains only one queen. So each and every column contains only one queen. First column contains only one cube. Second column contains only one queen. Third column contains only one queen. Fourth column contains only one queen. Fifth column contains only one queen. Sixth column contains only one queen. Seventh column contains only one queen. And eighth column contains only one queen. So no two queens are on the same row. No two queens are on the same column. No two queens are on the same diagonal. We have to check. So this diagonal, no queen is there. This diagonal, no queen is there. This diagonal, no two 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 queen is there. Okay. So after satisfying these three conditions, no two queens are on the same row, no two queens are on the same column, no two queens are on the same diagonal, the final solution vector is 8 tuple. The solution vector is 8 tuple. So the 8 tuples are: first queen can be placed on fourth column, second queen can be placed on sixth column, first queen can be placed on fourth column, second queen can be placed on sixth column, third queen can be placed on eighth column, fourth queen can be placed on second column, fifth queen can be placed on seventh column, sixth queen can be placed on first column, seventh queen can be placed on third column, eighth queen can be placed on fifth column. Okay, so 8 queens can be placed on 8 by 8 chessboard. Okay, this is the final solution for the given 8 queens problem. While we are placing 8 queens on 8 by 8 chessboard, such that no two queens are on the same row, no two queens are on the same column, no two queens are on the same diagonal. Okay, next. Suppose we can take any two coordinates I comma j and k comma l. We have to check these two coordinates are diagonal coordinates or not. Okay. So to checking these two coordinates that are whether they are diagonal coordinates or not, by using this formula, mod I minus k is equal to mod j minus l. Mod j minus l. By satisfying this condition, we can say that these two coordinates are diagonal coordinates in 8 by 8 chessboard. Suppose this condition is not satisfied, then we can say that so these two coordinates are not diagonal coordinates. Suppose we can take two pairs, that is 2 comma 7 and 3 comma 8. Check whether these two are diagonal elements or not. So here I value is 2, k value is 3, j value is 7, l value is 8. I value is 2, k value is 3, j value is 7, l value is 8. Okay, so that is mod minus 1 is equal to mod minus 1. So that is equal to mod 1 is equal to mod 1. Okay. So these two coordinates satisfies the condition. Then we can say that 2, 7 and 3, 8 are diagonal coordinates. So 2, 7, 3, 8, 2, 7 and 3, 8. These two coordinates are diagonal coordinates after satisfying this condition. Next, for this problem, all the solutions can be represented by using a state space tree. So after drawing state space tree like as 4 queens problem, how many number of nodes in the state space tree? So the formula is 1 plus sigma j is equal to 0 to 7 pi I is equal to 0 to j 8 minus I. So this formula is used for finding out how many number of nodes in the state space tree while you are placing 8 queens on 8 by 8 chessboard. So the total number of nodes is 69,821 nodes are there. So it is very difficult to draw 8 state space tree for 8 queens problem because so it contains 69,821 nodes. So the number of nodes in state space tree for 8 queens problem. Okay, so this is the description about how to place 8 queens on 8 by 8 chessboard. The total number of possibilities before applying any constraint is 64C8. After impose implicit constraints, so the total number of possibilities is 8 factorial. Next, the total number of nodes in the state space tree is 69,821 nodes. Next, the final solution for 8 queens problem is represented by 8 tuples. So that is x1, x2, x3, x4, x5, x6, x7, x8. So one queen can be placed on 4th column, second queen can be placed on 6th column, third queen can be placed on 8th column, fourth queen can be placed on 2nd column, fifth queen can be placed on 7th column, sixth queen can be placed on 1st column, seventh queen can be placed on 3rd column, eighth queen can be placed on 5th column. So here we are using two types of constraints. One is the explicit constraints and second one is implicit constraints. Explicit constraints are the rules that restrict each xi to take on values from a given set. So given set S suffix I contains only 8 column values, that is 1, 2, 3, 4, 5, 6, 7, 8. Now we have to place any queen, that is x suffix I, can take values from the given set. Either x suffix I can take either 1st column, 2nd column, 3rd column, 4th column, 5th column, 6th column, 7th column, 8th column. So x suffix I varied from 1 to 8. Next, implicit constraints are nothing but no two queens are on the same column or no two queens are on the same diagonal. Okay, so here n is equal to 8. So because of reason, it can be called as 8 queens problem. Actually, it is n queens problem. Suppose we can take n is equal to 8. It is a 8 queens problem. So this is the description about the 8 queens problem. So thank you for watching this video. If you like this video, please subscribe my channel, Dibbela Srinivas Rao. Thank you.